Time. Why? Where does it start? Where does it end? Before the Big Bang, time. Was there? Or will there be an end? When our solar system reaches the end of its life, when we disappear, time. Will it happen? Of everything, from all of us, independent of location. In a straight line. Is it something that flows? According to names such as Galileo and Newton, who are considered the fathers of classical physics, yes. Time is absolute, unchangeable, constant. It flows independently of everything. Especially when absolute time is mentioned, Newton comes to everyone's mind. But do you remember there was a young man working in a patent office in Bern? Do you know what he wrote in his diary one day? Newton, I am so sorry. Newton, Descartes, Galileo, Maxwell, and dozens of other scientists. Dozens of names that changed history. He was kind of dissing them all with this sentence. Gentlemen, I am sad. But that's not how it works, he said. Our rebellious young man, Albert Einstein. Someone who said the following when he was a student. This fact or that fact does not concern me. I want to learn God's way of thinking. The rest is just details for me. A man who died an hour before he died while trying to take his notebook and pen and write the theory of everything in order to take the last step necessary to unravel the mind of God. We will talk a lot about Einstein, with its good deeds and sins, with everything. My hands are so full about this man's life and perspective. But today we will talk about time. And in order to understand and explain time, we first need to go back in time, to where it all began. Do not worry, we will not go back to Greek mythology or the philosophers of ancient times. It is a subject that Aristotle and Copernicus pondered. If necessary, we can discuss it further, but back to the time when the phenomenon of time was first studied scientifically. Let's go back to the 16th century. What a century, right? Galileo, Newton, Barrow, Descartes. We are talking about an age of enlightenment dating back to the 17th century. And first of all, humanity studies time with Galileo Galilei. The concept of time, which will be accepted for centuries, almost took its final form with Isaac Barrow and Isaac Newton. According to all these scientists, time was absolute and universal, as we just mentioned. Time defined in this way is also called Newtonian time. And this concept of time, which is considered absolute, was the same for everyone, something that progressed at a constant speed at every point in the universe. Something that could be measured, but could not be perceived. In particular, Newton believed that time and space were completely separate elements of objective reality, and he believed that even if there was nothing left in the universe, it would continue to exist on its own. What did Shakespeare say? The world is a stage. And according to Newton, the only thing that did not change on this stage was time. Gravity, which radically changed the world, was the thing that he did not touch and accepted as constant while explaining the laws of motion. A problem that Newton could not solve in his lifetime. This is a problem that he thinks is a work of God that is not possible for us to perceive. The most obvious indicator of this was hidden in the movement of the planet Mercury in our solar system. Newton's laws could calculate everything exactly, from the motion of the apple to the orbit of the Earth. But Mercury did not comply with these calculations. There was always a deviation in its orbit. This is where he says, this must be God's work. In fact, some scientists, while trying to explain this, thought that there was another planet called Vulcan that we cannot see. However, this deviation in the orbit of the planet Mercury could be explained by the gravitational effect of another planet, but it wasn't there. No, he had no sun. There was no explanation why Mercury's orbit denied all laws. It wouldn't happen as long as time was constant. Now I want to ask you something here. It is very, very difficult, I know, but I want you to forget everything you know about time. How time passes, that it flows in a straight line, that we live and go in a line between birth and death, that time is the same for everyone, that everyone experiences the same time everywhere, regardless of where and how you live. Forget it. Because we need to completely destroy this perception, because it's wrong. It's all wrong. Who says this? Wilhelm Leibniz says this first. For Leibniz, there were events that happened before, after, or simultaneously with each other. Time was just a way of organizing these relationships in our minds. Then, Immanuel Kant joined independently from a more philosophical perspective. Immanuel Kant argued that time is not a self-existent thing or a sequence of relations between self-existent things. According to Kant, time was simply the way our minds organize the experiences we have. Kant argued that things that exist spontaneously outside our minds and independently of us do not actually exist in time. But Albert Einstein would put an end to all these discussions. In 1905, known as the miraculous year of physics and Einstein, he would publish 4 incredible studies, including the special theory of relativity, and later, after a camp period of more than 10 years, he would publish the general theory of relativity, making his name indelibly written in history. These are not things that can be explained in one sentence, and we will get into the details later. But let's not lose focus. We were talking about time. What is time? This was the question that most bothered Einstein, who was also a fan of Newton, because Einstein was sure of one thing after seeing Maxwell's equations. The only constant in the universe was the speed of light. The only thing that was constant, moving at the same speed regardless of where you looked or where you stood, was the movement of light. In this case, something had to change in Newton's laws. Things couldn't be fixed, especially time. It couldn't be constant. Let's proceed with an example, with a disaster scenario, a scenario in which the sun disappears. What if one day our sun suddenly disappeared in a way that we had not noticed before? If we consider this scenario with Newton's law of gravity, this is what will happen. The Earth instantly drops out of orbit and heads into outer space. Instantly. Because, according to Newton's law of gravity, you can think of it as if there is a rope between 2 objects that attract each other. It's as if the larger one is reaching out and holding the smaller object, a constant and momentary power. But according to Einstein, this is impossible, because the speed of light is constant in the universe, and nothing can exceed the speed of light. The speed of light is our universal limit, and it takes about 8 minutes for sunlight to reach our world. And since the gravitational force moves exactly at the speed of light, if the sun were to disappear right now, we would be able to live as if nothing had happened for 8 minutes. What happens next? That scenario is not very pleasant. We will speak later. This finding was one of the most important findings in the history of science. And here's the weird thing. We could live by Newton's laws. We wouldn't even be aware of it, because this is not a situation that we can perceive in daily life. Newton was able to calculate 99% accurately the movements of objects in our solar system, and as far as we can perceive in our daily lives. But that 1% that is not a problem for us was a problem for people like Einstein, and everything had to have an explanation. Einstein. How did he come to this conclusion? Einstein actually realized this when he was 16 years old. Einstein's thought experiments are famous. He could visualize any situation in his mind and look for answers through it. Here was a thought experiment he made at the age of 16, in which there was a train and 2 people. One is inside the train and one is outside, looking at the train. The train moves at a very high speed. Let's assume that there are 2 trees at the back of this train, 100 meters apart, and that lightning strikes these 2 trees at the same time. According to Einstein's thought experiment, this event occurs at the same time for the person standing outside the train. Lightning strikes both trees at the same time. But from the perspective of the person on the speeding train, lightning first strikes the first tree, and then, after a while, the next one. Are the concepts of relativity and relativity starting to make a little more sense now? Same incident, 2 different people, 2 different times. How is it possible? Now, let's try to understand how the speed of light is constant with a slightly different example. Speed, as we perceive it in daily life, is also relative and is calculated according to the reference point by adding and subtracting. So think of 2 cars. Let's say they are both moving at 60 kilometers per hour side by side. For people in 2 cars, the speed of the other car is 0 relative to their reference point, so it's not moving. But when the other one accelerates to 80 kilometers, that vehicle is moving at 20 kilometers for the vehicle traveling at 60 kilometers. This is the basic law. But at the speed of light, this doesn't work. For example, the speed of light is exactly 299,792,458 meters per second, but for ease of calculation, let's say 300 million meters per second. And let's build a spaceship, and let this spaceship go at a speed of 150 million meters per second and move next to a particle of light. Under normal circumstances, when we measure the speed of this light particle from this space shuttle, the result should be 150 million m per second, right? Not here. Whether you measure it from where you stand, reach half the speed of light, or 90 out of 100. No matter how you measure it, the speed of light will be exactly 299,792,458 meters per second. How? Let's explain. Well, let's try to explain. E equals sine mc2, the most known equation of physics. You must have heard of it. Here E is the energy, m is the mass c, 2 is the square of the speed of light. And when Einstein first wrote this equation, he wrote it as m equals sine E c2. Well, energy and mass can change places. That is, energy and mass. Hold on tight. Actually, same thing. In other words, everything you see, everything you know, everything we can hold and observe concretely, actually energy, you are made of energy, and we are talking about a very serious energy. Let's take a paperclip, for example. It's what we pin those papers to. If we could convert each atom that makes up this paperclip into energy, it would release an energy equivalent to an 18 kiloton TNT explosive. And this means a force close to the atomic bomb dropped on Hiroshima. We will talk about these too. But without deviating from the topic, this equation, therefore Einstein says this: as the speed of an object increases, its energy increases, and therefore its mass increases. And as it approaches the speed of light, it needs infinite energy, and therefore mass, to maintain this speed. And this is why it is impossible to exceed the speed of light. The main point here that pushes our limits of perception is this: according to the physics we perceive, speed multiplied by time equals sine distance. But when you put the speed of light into this equation, the laws of physics as we know them do not work. Because, as I said, the speed of light is constant. Therefore, there must be differences in time and distance. Let's wrap it up with one last example, if you want. Let's talk about twin brothers named David and Mary. Let them both be astronauts, and participate in an experiment to prove this law to us. Let David stay on Earth, and Mary stay at 99% of the speed of light. Let's say he went on a 1-year journey with a space shuttle that could reach 997. Assuming that they are both 30 years old when this journey begins, when David and Mary meet after a 1-year journey, Mary will naturally be 31 years old. But David, who remains in the world, will be exactly 81 years old. For someone moving at this speed, time will slow down much, much slower. And David and Mary will probably be the first twins with an age difference of 51 years. By the way, this theory was also proven in real life in 1971. In the experiment known as the Haffel-Keating experiment, they placed 2 of 3 synchronized atomic clocks on a plane in opposite directions, one to the east and the other to the west. The third is left at the airport. Planes land, and 3 atomic clocks are checked. They are no longer synchronized. The time of the plane flying east is 59 billionths of a second behind that of the one remaining at the airport. Those flying west are 273 billionths of a second behind. Isn't it very difficult to detect? The human mind cannot accept it. But perhaps even just one example that affects our daily lives may be enough to understand the importance of this theory. GPS systems, for example. Since the satellites in orbit move at very high speeds, there is a slight time difference, and this time difference is constantly synchronized. Otherwise, when you look at it from applications such as Google Map, your location could be deviated by kilometers, and we would not be able to locate anything exactly. And all this I mentioned was a very brief summary of the special theory of relativity published by Albert Einstein in 1905. If you are aware, I haven't talked about gravity and general relativity theory yet, or from the quantum world, where Einstein was also stuck. That's why I can say that we are just getting started. All the laws, theories, examples I mentioned. At some point, one may ask, What does this mean for my daily life? I don't even think about it sometimes. It's so hard to perceive. He wants to quit. But then I find myself thinking about the universe, and when thinking about the energy I just mentioned, all of us, of everything, that it consists of energy, of time. It's a complete illusion that everything, our perspective on events, troubles, worries, joys, sadness, everything is relative. It changes depending on how we look at it. When I think about all this, I say physics. It actually tells me about me, and it changes my whole perspective. It radically changes my perspective on life, the universe, everything that's going on, all social problems, politics, matter, psychology, myself. So, let's see what we will learn about ourselves in the next video. Shall we meet again at the first opportunity? Until then, take good care of yourself. And as always, so glad to have you. Best regards.